Hello, so today we'll be talking about Earth systems and resources, soil and soil dynamics. We're Mina Chua, Kelly Chung, Bobby Chen, Nathan Lai, Jana Ma, and Hubert Ko, and we're period 1 for Mr. Munoz. So how is soil created? So in the first step, you have to let bedrock disintegrate, which means the hard layer of rock begins to turn into smaller particles of soil. After this, organic matter is able to facilitate and disintegrate within the bedrock material, and then they're able to combine, and over time they can create horizons, such as the O horizon, the E horizon, the B horizon, and this is where different layers of organic matter is able to separate from each other. And then after horizons are formed, you're able to develop soil. You're able to develop vegetations and within the soil.
Hey, what's up, guys? Soil is a combination of organic material and rock that has been broken down by chemical and biological weathering. Water, wind, and living organisms are all prominent agents of weathering, and all weathering processes are placed into the following three categories, which are physical, chemical, and biological. For physical weathering, it is basically any process that breaks rock down into smaller pieces without changing the chemistry of the rock. The forces that are responsible for this are typically wind and water. Chemical weathering occurs when chemicals interact between water and other atmospheric gases. For example, rust. Rust, which forms when iron and other metallic elements come into contact with water. Biological weathering is weathering that takes place as a result of the activities of living organisms, such as tree roots growing and expanding through the rocks.
There are three types of soil. There's clay, silt, and sand. For clay, the soil has to be greater than 0.002 millimeters in diameter. Clay is the smallest size in between the three types of soil. It's sticky and it's extremely compact. The second type of soil is silt, and it is between 0.002 to 0.05 millimeters in diameter and has the ability to hold water well. The biggest type of soil is sand, which is 0.05 to 2 millimeters in diameter. This is the largest particle between all three types of soil, and water is able to filter through sand really easily, which means that it's very difficult to actually grow any type of vegetations in sand. Loam is when clay, silt, and sand are combined in equal proportions, and loam is normally a really good type of material for any individual to grow vegetations in. The different types of layers. There's a total of 6 types of horizons. There's the O, A, E, B, C, and R horizon. The O horizon holds organic litter. Basically, is anything from tree leaves to worms to anything that is basically organic. The second layer is one of the most important layers, which is topsoil, and is where all the plants start to grow and grow. Basically, it's where all the nutrients are going to be held. The E horizon is where leaching happens, which is when water is drained into the soil, and basically it gets held into the E horizon. The B, C, and R horizon are basically a more tougher layer of sand, and it's very difficult to grow in these type of areas, and they're basically less organic. Our horizon is basically the parent material, so it's really hard. It's basically like rock-like, so it's kind of not even soil anymore, but it's still part of the horizons. So some characteristics. For color, black and dark soil basically means that the soil is richer in organic matter. So it's it's better for individuals to grow vegetation in very dark soil. If soil is pale or white, that means it's low in organic matter. So typically, as you go down the different horizon layers, the top layers are more dark and the bottom layers are more white and pale. For texture, loamy texture means that, which I said before, is an even mixture of sand, silt, and clay. For porosity, this means that water flows more easily through the soil. When there's low porosity, then water can't flow easily through the soil, which means that all the water is just going to be trapped inside the sand. For high porosity, that means the water won't be trapped within the soil, and so it'll be difficult for the vegetations to absorb the water, which is necessary for it to grow. Characteristics continued. For structure, soil needs to be even in clumpiness. If they're too clumpy, then it's going to be difficult to grow. If it's less clumpy, then all the nutrients will just pass through, all the water will pass through. It'll be very difficult for it to contain any nutrients as well. There has to be constant tilling so that it'll be harder for water to absorb. For pH, there are different degrees in acidity. If pH is less than 7, then that means the soil is more acidic, and if pH is greater than 7, then that means the soil is more basic. If it's at 7, then it's neutral. Leaching is when the process of transporting minerals, and this can cause acids to remove nutrients from plants.
Erosion is a process in which soil and rock are removed from the ground's surface, and it's a process that is detrimental to a lot of vegetation and crops because it gets rid of a lot of nutrients. So there are 4 types of erosion. The first one is rill, and how it works is that water runs along small furrows. So as water keeps running through the gaps, they get wider and wider, and they start to deepen into channels, and this is when it becomes a rill. And this usually occurs when runoff water forms small channels and goes down slopes because gravity pulls the water down faster. And then the next type of erosion forms gullies, which are basically deeper versions of rills. They're formed from rills, and they cut deeper into the soil, and they expand even more as the erosion starts to continue. They can either occur from waterfalls or watercourses or places where runoff is really concentrated. The next type of erosion is splash erosion, which occurs when raindrops dislodge soil particles that fill in the gaps of the soil. And this also decreases the soil's ability to absorb water because the soil particles are basically dislodged once the raindrops hit the soil, and the soil particles start to run off with the water stream and they get lost. The last type of erosion is sheet erosion. This is when water flows in thin sheets over the soil surfaces and the topsoil is washed away in uniform layers, and this also usually occurs during hill slopes. These areas are more prone to sheet erosion because they're facing downward.
Okay, desertification is where fertile areas turn into deserts. That is to say, when places and areas that originally could support and sustain plant life turn to deserts, which can't. That just means there are less nutrients to grow crops. The climate will change as a result of the desertification, and human activities usually cause this. This can lead to the formation of giant dust clouds that block out the sun or create economic disturbances that don't usually end well for the society. Other natural disasters that could happen are earthquakes, which are caused by internal geothermal energy. More commonly, we just think of earthquakes as when 2 tectonic plates shift at a fault line that jars the earth enough to cause violent tremors throughout the land. And a tsunami is a series of large waves generated when part of the ocean floor suddenly rises or drops, usually again at a fault line. Salinization. Now, salinization is the accumulation of salts in soil. This is very harmful to plants because plants can only tolerate a certain amount of salt in the water that they intake. Overwatering crops can bring salt into the soil from the top of the soil and can damage the top layers of the soil. Coastal areas often have this problem because of the proximity to the ocean, which obviously has salt water. There is a process known as desalinization where people are able to take salt away from the water and other sources, but that takes money and it takes extra energy input. And now there are several ways to conserve soil. There are several ways to make it last longer. People can try no-till farming, which means that you don't uproot the ground every single time you put a new round of crops in. Crops are more anchored in place and the soil isn't exposed to as much wind and water, which means it wouldn't be able to erode as much. You could prevent overgrazing. That means if too many animals are grazing off a small area, then the soil will start to erode as the roots of the plants start dying. If there's no roots holding the soil together, then the soil can just blow in the wind or get washed away by water. Also, crop rotation. Alternating between deep-rooted and shallow-rooted plants gives the soil time to regenerate nutrients and prevents the accumulation of pathogens and pests in the soil.